Hello, everyone. I welcome you all to this course on C programming, uh, which myself and Professor Shengupta plan to float in the YouTube. Okay, so what the total plan is that we are trying to, discuss about all the concepts of C programming step by step, and we will try to solve some programs. We will try to explain some of the programs in this particular course. So today I just wanted to introduce you with C programming. I mean, what exactly we are going to do in this course. And not only that, I just wanted to give you an introduction to programming rather than moving into the exact C programming concepts. Okay, so let us begin today's class with some concepts that I feel is necessary when you start any programming language. Okay, so here is the learning objective. Why do we need a programming language? I'll just talk very briefly. What is a programming language? Now, of course, we are writing programs using a computer. If that is so, we must know what is it and how does it actually work. And ultimately, because we are going to use the computer to execute our programs or to write our programs as well as execute our program. Now, this is also something important because I believe the C programming is a kind of course which will be taken by diverse students. It is not only computer science students will be doing this course. This course may be done by many other students. And for that reason, we must also understand that not only how does a computer work, but why it is only understands this binary thing. So we will also discuss that, and then very briefly on number system, basically not much. And then I'll just tell you that what is an application software and what is an application software and what is just the kind of softwares that we use it. Okay. These are the reference book that basically you can follow for this particular course. These are the two books. I mean, this is just a suggestion. There are many other books. You can follow anything you want. Coming to why do we need a programming language? So just think of it in this way, that it would be really good if we can just provide some commands to computer and they perform that task. And if it is a kind of repeated things, and if you can write something well in advance, and every time you need the result, you just run it and you get the result, it would be really good. And so computer programs are needed for one of the reason is like we wanted to perform some kind of repetitive task time and again, and we use programming language for it. Now you see that everything that you use, you think of a Microsoft Word program that you are running. You think of any of the applications that you are running on your mobile. Anything, any software which you download must have been written using some programming languages. So it allows us to basically write applications, softwares, everything, right? So these are the reason why programming languages are of utmost importance. And as I said, any software that you use today, it can be, if it can be a part of your business. If you see the healthcare system, you see the automobile business, the education, the entertainment, if you see any kind of business, you need some kind of software, you need some kind of application. And each of this application are specific to the kind of task which is required, application specific. So these are the reason for which we really need a programming language. Moving on, what is a programming language? Now, as I said, we need to perform certain tasks easily. And for that reason, we need to inform or we need to instruct the computer that we need to do this. And the computer should be able to understand it, right? So a programming language is nothing but a way which we human can understand, through which we instruct the computer to perform certain tasks. Okay. And there are certain rules when you write such kind of program, right? So there are certain basic constructs of a programming language, like you call it language syntax, you call it, there are certain variables, there are certain constants, there are certain data types, and so on and so forth. We will be looking into when we look for this programming language, which is C here, but for any programming language. So there are some basic constructs which must be followed. And some common programming languages are C, C++, Java, Python, R, JavaScript. There are many more, right? I just jotted down a few of them. I hope why we need a programming language and what is a programming language is clear to us. I'm not going into details of it. Let us move on and understand what is a computer. So computer is basically a system which takes input, processes that input, and generates the output, right? Now, in this process, we must understand one thing, that whenever we are saying that our computer takes input, processes that input, and generates that output, how it is actually doing it. This is something we need to understand. And in this process, just think of the way our brain works. How do you remember that every morning when you get up, you go to bathroom, you brush your teeth, you then take bath, then come, then take your breakfast, go to school, go to college, some goes to work. So there is a particular program which is written in our brain and through which we perform all the tasks, right? So something is stored somewhere and we know that these are the steps that are required and step by step it is followed. So there is something which we call it memory. In the same way, computer has got a memory. Okay, there are various kinds of memory, types of memory. We are not going to details of it here, but for now you understand that whatever needs to be performed must be written in memory in the form of instructions. Fine. Instructions are stored in memory, and every time these instructions are brought into the processor, it processes it, and finally either it sends it back to the main memory or it sends it back to the output device. And of course, we need certain storage devices because everything cannot be stored in our main memory. Many of these programs and many of the data are also stored in our secondary storage. So this is the basic idea. We get the input, we process the input, we generate the output. How do we process it? The instructions are stored in memory. Each time we need to process it, we bring it to the processor and then we execute it. This is very simple. Now think of it. You have a programming language. There you will be writing some code, right? Some set of instructions. That instruction must be executed, must be processed, and then you get the output. Now you see a very simple thing. You are writing the program through your, keyboard. That's your input device. It gets processed. We will see how it gets processed for C language in course of time. But generally, let's assume that it gets processed. And then you again see the output of your program in an output device, which is your monitor, right? So if you see this whole process of writing a code, executing a code, and then getting output, so the whole computer does it in some way or the other, okay? Along with this, these are the things that are required. I mean, just a photo of it. This is a memory chip. This is a processor chip, which contains many other components as well. This is your mouse and keyboard, and this is your hard disk. Okay, so these are the different components that are required to build a computer. Let's move on. Now, specifically, if we talk about central processing unit, what is it? It is basically the heart of your computer. It is the brain of your computer, which processes the most important thing. But remember that whatever it processes, it brings it from the memory and process it. CPU is for processing. And most importantly, CPU has two important parts. One, we call it control unit, and another is called arithmetic and logic unit. These are the basic two units you have got. Arithmetic and logic unit is responsible for all arithmetic and logical operation. And your control unit basically generates the control signals that are required to execute that particular instruction or the whole program in some way, but step by step. Each instruction, how each instruction get executed, it should generate a particular control signal, and for so on and so forth. Okay. The most important thing, it retrieves instruction from memory, interpret, or we call it decode the instruction, and then perform the required operation. It executed. So we fetch the data, we execute the data, and then we finally, we fetch, we execute. This is the whole process. So this is very briefly on CPU. Now, main memory. As I told you, there are many types of memory. There are cache memory, there are registers, there are your main memory. Each of these are, so there are different kinds of memory. But when we consider main memory, we call it basically the memory where we store the most amount of data. Not exactly most amount of data, but the active data that we keep. Because when you switch on your computer, the first thing that happens is your operating system gets loaded into some part of your main memory. And then in the rest of the part, all your active programs, whichever you're running, it gets loaded one by one. So main memory is very, very important. And how it is built? It is built using some semiconductor technology. Now, I will come to the point that where I will talk about that how a computer is built using what is the basic component using which a computer is built. There we will talk very briefly on transistor, but we use some kind of technology. We call it semiconductor technology. And generally, main memory is built using DRAM, dynamic random access memory. The size of the memory typically ranges from 4 to 16 gigabyte. There are even more. There are, 24, 32 gigabyte, 48 gigabyte memories also. They're possible in today's computer. So some of the measures that we will remember, we will discuss more when we typically write a program, execute it, and then see what is happening in the memory. Because as I told you, everything, whatever we are doing will be first loaded in memory, and step by step it will be done. So, but for now, you just understand when we say 1 kilobyte or 1K, it is 2 to the power 10, 1M is 2 to the power 20, giga means 2 to the power 30, tera is 2 to the power 40, and peta means 2 to the power 50. This is for your understanding. Let's move on. Now, again, input-output devices, you know most of the input-output devices, and there are storage devices as well. So most common input devices are your keyboard, mouse, scanner, etc. And output devices, your monitor, printer. Currently, if you see the hard disk, which is present in most of the computer, they are SSDs, solid state drive. Okay, they are much faster, as well as they can store more amount of data. Okay, so these are some typical types, which I'm not going into the details of it, but you must know that what is storage. I mean, what kind of storage devices are used in our computer. So we use SSDs in today's. Now let us understand very briefly on how a computer works, right? So I have already told you that how a computer works. So typically, what we will do here that, let us come here, that this is your processor, right? This is your processor and this is your memory. If you see what is said here, instructions to perform some calculation is stored in memory. So whatever you are going to process in the processor, it must be stored in memory. So it must be stored in the memory in the form of some instructions. Instruction 1, instruction 2, and so on and so on. Okay. What are these instructions? These instructions are part of your bigger program. Suppose you want to execute a program, that program will have some instructions, and these instructions are loaded in memory. And each time you want to execute it, you bring this instruction from memory to processor and execute it. Then go to the next one, bring it from memory to processor and execute it. How it is done, it is always discussed in some other course, but this is the general procedure of how we actually execute a particular program in memory. It is nothing. What is a program? Set of instruction. How do we execute it? We store it in memory and we bring from memory to processor one by one and it gets executed. Okay. So this is all about it. It uses a stored program concept I just mentioned. What is a program? It is a set of instructions for carrying out that particular task. And finally, you must understand where our program is stored. I told you, when you are writing the program, you are first storing it in secondary memory, okay, your hard disk. But when you are executing it, when you are running it, it must be brought from your secondary storage to your primary storage. We call it main memory. Okay. So when you are executing, it is in your main memory. So these are the two things you must remember. We write a program, we store it in our storage. Okay. But when you execute it, so you write your program, you have saved it somewhere, right? It is in your secondary store. But when you are executing it, when you are running that program, that is mean the program is brought into main memory and then we are executing. That is the whole process. Right? So these are something which you must remember. Let me clear this and move on. Now, this is one thing we must understand, that computer can only understand 0 and 1. And why that is so? What is the reason behind it? How a computer is built? So if you just, the most basic thing using which our circuits or gates are built is transistor. Using this transistor, what we make? First, we make gates. What gates? Logic gates. AND gate, OR gate, NAND gate, NOR gate, all these gates. Okay. Using these gates, then what we make? We make circuits. Right? What are these circuits? These are the circuits which are there in computer, like an adder circuit, which adds certain number. There is a multiplier circuit, which multiplies. There is a division circuit, and so on and so forth. Right? So, from the transistor, we build gates. With the gates, we build circuits. And what is a computer? Computer is nothing but many of the circuits together to form a system, which consists of many, many circuits. So this system, it has got many circuits. You have some which is performing certain tasks, arithmetic logic unit, that is kind of circuit that you have. There will be control unit. There will be many, many, many things. Okay, many, many circuits together, which is performing the whole task of your computer. You're taking input device, you are processing it, you're storing it in memory, you are outputting it, everything. There are many such kind of circuits present which combines together and it delivers your task. But the basic thing is transistor. And what is that? The computer is built, a digital computer is built out of tiny electronic switches. And these tiny electronic switches are built using transistors. And what it understands, you apply certain voltage, depending on how it is, whether it is a p-type transistor or it is an n-type transistor. It, of course, you have studied in physics, right? What is a p-type transistor? What is an n-type transistor? So depending on the voltage, application of your voltage, whether it will be there will be a conducting path from VDD to ground or there will be no path from VDD to ground, it decides, right? So from the viewpoint of ease of manufacturing and readability, we say that these switches can be one of these states, okay? Either it is on or it is off. And when we think of this on and off, a switch can represent this digit, in the so-called binary system with two logic states. That is why when it is on, we say logic 1. When it is off, it is logic 0. And why this is so? This is simply because the way it is built using these components, transistor, and the way these transistors work. Okay, it works on the basis of an voltage, and when we say that it is conducting, it is roughly certain volt, and when it is not conducting, it is close to, let's say, 0 volt. Okay, so it is either logic 0 or logic 1, which corresponds to some volt. Okay, so this is the primary reason the computer can only understand 0 and 1. The way using which it is built, they understand that, and the way how it is built, all the other things works in that way. So that is why a computer works based on binary number system. So I'm not going into the details of number system again, but to give you a very brief idea of number system, we know what is a decimal number system, right? We know what is a decimal number system. Now, one thing I just wanted to tell you, that in the previous slide, when I say that computer can only understand 0 and 1, that means everything that is written in the computer, in memory, in processor, everything is based on 0 and 1. So this, keep it in mind. Okay, all your data, all your instructions, everything is converted in computer in the form of 0 and 1. Fine? Okay. Coming to decimal number system, you have digit from 0 to 9, and every digit position has a weight. For example, if you take 234, so this is 0, 1, and 2, right? So this will be 2 multiplied by 10 to the power 2, 3 multiplied by 10 to the power 1, and 4 multiplied by 10 to the power 0, which if you add, you will get 234. Similarly, you can do this as well. So this is 0, 1, 2, and this is -1 and -2, and so on and so forth. This is how it works. And you can just do 2 multiplied by 10 to the power 2, and so on and so forth. And you add it up and you get that particular number. Okay, this is the so-called decimal number system. Now, moving to our concern is binary number system, because our computer works on binary number system. 2 digit, 0 and 1. Every digit position has a weight which is a power of 2. In decimal, it was a power of 10. And in binary, it is a power of 2. So if this is your binary number, 1110, then again, it is 0, 1, 2, and 3. So 1 into 2 to the power 3, 1 into 2 to the power 2, 1 into 2 to the power 1, and 0 into 2 to the power 0, which is nothing but 14 in decimal, right? This is how we basically convert a binary number into a decimal number. Okay. For your understanding, like of course, this is a programming language, but you will see that in course of time, if you are from computer science background, you will be learning all of this in some course or the other, where you learn the entire binary system, decimal system, how addition and multiplication and everything is done in binary system. And in the same way, we need some mechanism to do it in our computer. And it is already there here, which is performed using the circuits and the chips that we already have inside it. Okay. Now, this is also important concept of bits and bytes. What are bits? Bits are single digits, 0, 1, 0, 1, 1, 0. So this is 1 bit, this is 1 bit. These are 1, 1, 1. And what is nibble? Nibble is nothing but 4 bit together forms a nibble. Okay. So this is 0, 1, 1, 0, 0, 1, 0, 1. So we are combining 4 bits together here and 4 bits together here, which is called, these are 2 nibbles, 1 nibble of 4 bits. But generally we use byte. Our computers are byte addressable, which is a collection of 8 bits. Okay. So generally when you will see that even in when we learn about data types and everything that we will be using in C language, we will see that we are representing most of the things in terms of byte, which is 8 bits. 1 byte is 8 bits. Now, mostly this word, it depends on the computer. Sometime you must have heard of, it's a 32-bit computer, it's a 64-bit computer, it's a 128-bit computer. What does it mean? That means it is a collection of some byte together. Typically it is 4, 8, 16, like that. These many bytes. So the word size, you can access the entire 32 bits of data one at a time. When you read from memory and bring it to processor, you can directly access the 32-bit or 64-bit. So it depends on the machine and what you are using. Okay. So this is the concept of bits and bytes. We will be looking into more details when we do some programs, and we will see how the output works. Let's move on. So we have come almost to the end of this lecture, and let us also understand, when we say that using these computer programs, we will be writing some kind of, it's a kind of program that we will be writing. So there are, we call it, of course, some kind of software. So what kind of softwares generally we have? We have one category, we call it application software. Another category is system software. Okay. So what are application software? You see any of the application that you are using. VLC Media, it's an application software. What it is doing? It is running some videos or audios in my machine. Okay. It's an application software. Editor, financial accounting, weather forecasting, mathematical toolbox, all of these, any kind of application you are having, these are all called, these are softwares. What are softwares? Softwares are nothing but set of codes that is written to perform a particular task. But these are all called application software. These are specific to certain application. When we call a system software, you just think of, if you have a computer, you have the processor, you have the memory and all other components, but you do not have the operating system, then what I will do? I will not be able to switch on this computer only, because there is no way that the user can interact with the hardware of the computer, right? So for that reason, the most important software that is needed to even run any of these application software, these application software is of no use if you do not have a system software, right? So an operating system is called a system software, also a compiler. You know, when we are writing certain programs, we will see that we need some kind of compiler that is required to convert your program to run on a particular machine. So system softwares are very, very important. And as I said, once you have a system software, you will be able to do all your tasks, like writing application, running application programs, and everything else. Okay. So I've come to an end of this lecture. we will start technically with C programming from next week onwards. I hope you like this, and we hope that we are able to give you a very good concept of C programming so that you independently can write programs. Thank you.